I'm your host, Bill Murphy, for ASP Enterprises and Bowman Construction Supply. And I'm also with Quick and Cascade, but we don't we're not the master distributor for Quick or Tensar out of Quick and Cascade, so I'll move past that quickly. About us, I do this intro at the beginning of all of our webinars, and I'll go over some things that some of you are familiar with, but for those of you that are new to us, it's good to kind of fill you in on what to expect. We are a distributor of construction supply materials. We've been in business in over 47 years in a number of our locations, and we have well over 12,000 customers. We have one engineer on staff for all of our companies, that's me, and we have a number of CPESs and a whole lot of technical salespeople who are experts in what they do every day, happy to answer your questions. And what's proven to be very valuable the last several years is to be very good at warehousing and shipping and logistics and getting materials to the job site. Again, we're not in all of these states with Tensar. I am. So I'll jump right to some of our other solutions. We're going to talk about a kind of specific couple of applications today with our guest speaker. But just to remind you folks, if you have questions on any sediment and erosion control, geosynthetics, revegetation, hardscapes in some of our locations, just give us a call. If we don't have it, we'll point you to somebody who does. We're very good at advice, whether it benefits us that day or not. Again, I'm proud of our logistics and trucking folks, the people that order our materials and stock them in the warehouse, people that put together orders. As you can see on these trucks, they deliver a variety of different products to one job at a time.
Well, I'm going to click through here, go to my first. Okay, it's working. Step one out of the way. A lot of times you're a little nervous about that, but my background is, as mentioned, went to University of Arkansas in Fayetteville. Achieved my Bachelor of Science in Civil Engineering. And my work history, you can look through it there, but basically I've been able to do just about anything that this audience has dealt with, whether it's designing a water line for a public works project, whether it's testing soils, geotechnical engineering, materials testing concrete, working for developers and land development and learning that interest clock doesn't stop ticking and time matters. So anyway, I pretty much filled about any question that comes as far as those aspects. And as was mentioned earlier, this is back when I had hair and I was ignorant. I'm been able to hold on to the ignorance, but the hair is long gone. So anyway, I like to tell people that I was an offensive lineman when they find out I was a former Razorback. But as you can tell by my deal, at that time I was 168. I've gained about 10 pounds, but I'm not big enough. But I don't give PDHs for talking football, but I love it. So if you want to reach out to me, I'll be more than happy to talk football. When Bill and I were working through this, please do not read this screen. Bill and I were working through this. There's a little bit of a delay in the transition, so I apologize if it's going to be, I'll try to make it as smooth as I can, but this excerpt is just from a geotechnical engineering report that I just pulled up and looked through. I'll break it down by paragraph. If you look at paragraph 1, and there's a lot of, if the exposed soils are unstable, if the construction time, again, that's if, I'm gonna have to move this, the camera's blocking part of my deal. Stable subgrade may not be achievable. Further undercuts may also be performed. So you can see here, there's a lot of uncertainty just in this paragraph alone. And I was told a long time ago that question marks lead to dollar signs. You probably all have heard that, but a lot of question marks in this. And then they also throw in this, if the thickness of the soft soil is greater than 1 to 1.5 foot. Again, a lot of question marks in that paragraph. Moving to paragraph 2, for budgeting purposes, and when this is in a report, a lot of times there's a lot of, I don't know if this is a word, but conservativity. Generally, you get a conservative approach whenever they're asked to provide budgeting purposes. And then the third paragraph, you look here, more detailed recommendations can be provided during construction. And we need to keep the end user in mind when we're looking at these geotech reports. And, moving on, I blacked out this section because it identifies the company, but here they throw out 2.5 foot undercut depth, bridging lift 24 inches or more. And then this one's a tricky one. The thickness of the bridging lift will depend on site conditions at the time of site grading. So I just quickly broke down that paragraph, and there's some questions. And first off, how does a contractor bid this project or even provide a budget number with this information? A lot of times you get a conservative budget number, just like the Geotech in this report put out there. They're probably looking at 5 foot undercut. What happens if less undercut is necessary or more undercuts necessary? Well, then it becomes many of you seen it. It's finger pointing session in the field. You have either your testing lab, they'll look at from station to station and come up with a thickness. Well, usually that guy's sitting there with somebody looking over his shoulder, making sure you got it right. Or you have to spend money for a surveyor to come out and shoot actual grades and then put that into a computer program model. And this one, I never understood this, and this is why it led me to Tensar. I've been designing with Tensar products for over 15 years now, but how do you allow for the benefit of a bridging lift when it comes to supporting the design traffic? In other words, if you have a 2 foot thick lift of bridging material, how many more easels does that give you when you're looking at the pavement surface? So that's where Geogrid allows for you to calculate that with accuracy. And what I always liked about incorporating a Geogrid recommendation, if you have the correct parameters, is it takes shooting from the hip out of the equation. We see a lot of shooting from the hip, and a lot of times you get a result that is similar to this. This is the worst nightmare for everybody. You come up with a recommendation, you proofroll it, and it fails. The contractor's upset, the engineer's scared to death, the city doesn't like it. So then this is what we're trying to avoid, this right here. Okay, so some of the key terms for today, CBR and subgrade modulus. Basically, those are fancy terms. A lot of you may know them, but it's for the strength of the subgrade. That's the #1 factor for the design input that we look at when we come up with a recommended section. And of course, we'll be talking about primarily Geogrid. And then another key term is performance. Within all families of geosynthetics, whether it's fabric, asphalt reinforcement, Geogrid, there's differing levels of performance within each product. So a lot of you probably know these uses of Geogrid, but I'll just run through them real quick. Paved and unpaved roads, access or haul roads. Maybe you just need to get out to the site to be able to build it, and it may be a temporary haul road. Shallow utility cover, which is a lot of areas we're seeing a lot of sprawl. So we're going into areas where we have old buildings and we're demoing the buildings. Well, then you have a spider web of shallow utilities. So it allows you to not have to undercut or reroute utilities. Which leads me to the most common question that I'm asked is, well, what if we have the grid down? What do we do? Well, you can trench right through it. You don't need any special heavy equipment or remove some of the gravel and hand cut it. You just take your backhoe or track hoe and just excavate through the grid. And you can actually drill through it. We partner with GeoPeer on a lot of projects where they just need a platform to drill through and install their GeoPeer system. And you can actually drill through our grid as well. So moving on, soft soil conditions, which is the reason Geogrid was invented back originally in the late 60s and 70s. Have a lot of rail applications, working platforms if it's a crane platform, bridge abutments. We have walls and slopes, reinforced slopes, and all of these above. Tensar has people in place such as me. That's what we're here to do, is to help you come up with a design recommendation, whether it's before construction or during construction, and we can help you out with that. And then the number one reason for Geogrid is generate some construction cost and time savings. And just basically how it works, the aggregate or the rock strikes through the openings in the grid, which puts the grid into tension and distributes the load over a soft subgrade. And it's placed on the subgrade. The subgrade has to be relatively flat. It doesn't need to be perfectly rolled. Any track hoe operator, while you're doing your clearing and grubbing, you can get it flat enough for our purposes. This is what we don't want. This was, they had a failed proof roll and didn't fill in the ruts, and this is not relatively flat. It needs to be flatter than this. So just for a little reference there. So I mentioned performance as one of the key terms for today. And in order to discuss performance, I think it's the easiest way is to go through the history of Geogrid and the performance of Geogrids. The Geogrids I'll talk about, Tensar's grids are all made in the USA. They're down in Morrow, Georgia, just outside of Atlanta. So I have on the left-hand side, ancient technology, I call it. And then on the right-hand side, now old technology. And the ones in red are kind of the go-to. So in the ancient technology, these are the biaxial geogrids, the BX1100, BX1200. And then what I'm calling old technology are the triaxial geogrids. And as you can see, those kind of the go-tos as far as the ones highlighted in red. And the difference between the two, the biaxial geogrids, referred to as biax, they were developed to distribute loads, and because of the alignment of the apertures and the nodes, they transfer loads linearly. Whereas triaxial geogrids, you put a group of triangles together, 6 triangles creates a hexagon, which allows you to distribute loads radially in a 360-degree pattern. Oh, and I forgot I have a sample here. Before we move on, this is the triaxial geogrid. Many of you may have seen it, polypropylene. And again, the 6 triangles create the hexagon. And also to be noted, there's one less node, or one more leg to each node for each let me back up. 2 additional legs to each node as opposed to biaxial grid. Then beyond that, we developed what's called a filter grid. And it's basically our grids. We have a triaxial geogrid and then our interaxial grid, which I'll introduce here in a little bit. They have an attached 6-ounce, some of them have 8-ounce non-woven fabric. And the benefit of that is this site here is by the Mississippi River, silty soils, non-cohesive. The fabric attached to the grid allows you to keep the separation between the soft, non-cohesive silt and the aggregate that goes on top of the geogrid. And here you can see the rolls of, it looks just like a geogrid fabric. The thing that contractors like this because it's one application. You don't have to carry around the heavy rolls of fabric with a skid steer or track hoe. You can, one person on each end of this roll, you can lift it, place it, and then kick it out and install your gravel. And here you can see we were able to build on it. And then the newest is Interax Geogrid. And you can see we're continuing with, we saw that the hexagon shape really worked well. Well, and there were, from what I understand, nearly 100 different iterations of this grid. But we have an floating hexagon, which is just a little bit thinner than the outer hexagon. It allows for a broader spectrum of aggregate sizes. You know, like the triaxial geogrid, we have anywhere from TX130 to TX190. And the difference in those is primarily the shape of the opening to accommodate different aggregate sizes, whereas Interax can, again, has a broader range. And this is the Interax, and I'm hoping you can see here, it has a white outer coating and the standard, you know, the polypropylene black on the inside. And the reason for that is the white coating, you can actually, if you push hard enough and you have a hard enough thumbnail, you can slightly indent this white coating. And this is co-extruded, so it's not going to separate. But what that does is it allows for more of a lock-in, mechanically stabilized rock layer. So that is, you're looking at performance. The spectrum is from left to right here. Left is unstabilized, which is before we had any geogrid. Then we have the biaxial geogrid that was invented in the early, well, it was actually late 70s, but 84 is when we really started honing in on our design methodologies. Triaxial geogrid was in 07, and then our Interax is in 21. And here you can see it's the same, you know, the CBR, I mentioned that key term earlier. Based on the same strength, soil strength, you can tell we're thinning up our sections each time we move up in our geogrid. And these are, each one of these represent the lowest performing geogrid of that family. So if you look at it as far as communications, you know, back before we had grid, we had the carrier pigeon. And I like to call this, in 84, the Zach Morris phone came out, and that'll age a lot of folks, but Saved by the Bell, Zach Morris, he was cool because he had this big old brick phone.
My wife will get a kick out of that one. I'll have to let her know.
Yeah. And then in 07, Apple came out with the iPhone, which I swore would not fly because I knew I would probably break the screen. But here we all, you know, 90% of people have iPhones. And then in 21, you know, we had the iPhone 12 come out. So that kind of aligns it with kind of a technology of communications. A couple of public service announcements that I call this my public service announcement section. I see this a lot in Kansas and Missouri, where there's highway plans that come out and they just say Geogrid. And whenever I call the designer, I ask them, what were we doing here? What type of grid, and what was your approach? Well, they say, well, we have a qualified products list or an approved products list, and they pick the Geogrid off of that. Well, most of the time when you're bidding a job, you pick the contractors in order to get a competitive advantage. They'll pick the cheapest Geogrid. Well, that also means that it's the lowest performing Geogrid. So they say, well, we're stuck with that or equal clause. Well, back in 2019, FHWA stepped out and said, you know what, we're going to allow for you to spec proprietary products. In other words, you can say, in your plans, you can call out Interax NX850 or whatever the case may be. And then beyond that, back in 74, there's a court case where they wanted to allow for spec and proprietary products. Well, I was actually at a presentation when this came up, and I don't know the date, but apparently several weeks ago, whenever this was put out, again, it's fairly recent, Supreme Court actually backed that up. So at the highest level, it is actually allowed. And then for the engineers out there, I know it's been tough to get professional development hours. You can go to our education portal on our website, and you can have well over a year's worth of PDHs. It's for free, and it's on your time. And then the blog is a handy tool as well. You go into our blog, and I still use it quite a bit. You enter a keyword search and say expansive soils with Geogrid. It'll kick back the research that was done for that specific topic. And some of the research, just to give you an idea on the level of research, this was a smart rock. And we partnered with Penn State in developing this smart rock. And basically, it was put in the middle of a railroad ballast, and it would record the rotation and the movement of that smart rock within that section as trains would go over the rail. Here's the output. You're able to see the particle movement vertically, and then the bottom one is rotationally. And those are on the left-hand side without Geogrid and on the right-hand side with Geogrid. So basically, you can see it mechanically stabilizes that rock and locks that section in tighter. And they also, this goes back on the performance. You can see without Geogrid, you get quite a bit of rotation. With the biaxial grid, quite a bit less, and then triaxial even less than that. So that kind of stuff is on our website. You can nerd out if you want. Plenty of information there for you. So we're looking at the two primary applications for geogrids. First off is, and I'm looking at myself in the camera, and I'm not in a dark room. It's just, unfortunately, we're remodeling my office, and I had to move to this room, so I apologize. But the first application is subgrade stabilization, and that's simply, soft subgrade. This is a book. I actually found this in our attic. We used to read this to our boys, and it's a silly book. It's about these dogs who are driving this bone truck, and it gets stuck, and that's what the whole book's about. It's a silly book, but we all deal with silly people day to day. And of course, some of them are these drivers, they don't quite pay attention. And this is a good representation of soft subgrade and also stabilized subgrade. This is actually a bike trail where they just needed to get it stable enough to where they could place asphalt. And they had been hauling hundreds of loads backing down this trail, and this particular driver just wasn't quite paying attention. So once we got everything stabilized, and we were able to place our asphalt and compact it, and it's being used now. So the number one thing to consider, like I mentioned, is subgrade strengths. I actually put a little deal on our blog, and Geosynthetics magazine actually published it. Surprised me. I just happened to see it. I don't mind it, but they didn't call me and say, hey, we're looking at publishing your blog. But basically, what I do in this blog is break down the different, break down the different ways of evaluating subgrade. And you have a Geotech report. You may or may not have a Geotech report, but that's one tool. The other tool is during construction, you can proof roll or use a probe rod, which, a lot of people have heard them call it poking it with a stick to see how firm your subgrade is. And those are nice, fine and dandy, but really what you need is something to design to. And that's where the dynamic cone pentometer allows you to do that. You can see here the picture. It's basically a hammer of a known weight, raised and dropped a known height with a rod tip that is calibrated, and it's quick. Actually, after we're through here, I'm going to a job site to do the same thing, and it can take half an hour to get a lot of information on a particular area. It's per ASTM standard. There's nobody that's making money just to have buy my product type deal. Mine's Kessler, and it's per ASTM standard, and it gives you the modulus and CBR values that we need to come up with an accurate design for stabilizing the subgrade.
Can I interrupt here just for a second? You mentioned
Absolutely.
earlier about nerding out. Man, I'm geeking out on this. So I first used these in college back in the early 90s at Iowa State University. And then after that, I've used it just a couple of times with different folks like yourself who are reps or some geotechs. But our company has them. Mark Sternman, I should have asked him to join us. Mark, I think you may be the one that trained him how to use one of these out of St. Louis. but he did a presentation for our company a couple of years ago about it. And then I think Ryan Anderson in Colorado has one now too. But we keep ours in a nice, expensive travel case. Looks like we're carrying a bow and arrow or a nice high power rifle. But we keep these around the back of the truck. They travel in a case. We take good care of them. But if we're not available, are you or somebody like you in one of your other states that we deal with available to help us with this?
We are. In fact, Mark and I have a good working relationship in that if somebody, a lot of times you need information right now. It may be, I may be tied up. Mark has on several occasions gone out and provided DCP testing, gave me the data, I broke it down and provided the design. Then there's sometimes when I'm available and I carry this in my truck 100% of the time. I have a toolbox, and it's such a useful tool that I'll go and do testing, and we don't charge anything to evaluate subgrade. More than anything, as a licensed engineer, I like that warm, fuzzy feeling that engineers like to have when you have all the data that you can gather in making a recommendation. So yeah, I actually just replaced my drive rod today. Finally have a warm day to where I could go out and replace it because I had wore it out, rounded off the threads on it. So some of the frequently asked questions, one was, can we excavate through Geogrid? This is another one. Well, why don't we use this biaxial Geogrid? It's cheaper. Well, it is on the front end as far as the cost of the grid, but if you look at it as a system, it actually costs more. And we'll go through a little exercise here just to put dollar values to it. Here you can see we have a unstabilized section and a section stabilized with biaxial Geogrid. And for a CBR value of 1.1, as we show here, we're able to reduce 7 inches of gravel. If you look at a TX130, which again, TX130, TX140, they perform about the same. It's the lowest performing triaxial grid. You're able to whittle away 4 more inches of gravel. So if we compare just the TX with the BX, this is a nifty little card. When I present to contractors, everybody kind of piques their interest and I end up giving it out. If you want a copy of this, it's on our website, or I'll be more than happy to send it. But this is based on aggregate cost per ton. Right now, $25 for my region is kind of the number I'm hearing. St. Louis, you do have more access to aggregate. It's cheaper. And then, of course, in Western Kansas, it's more expensive. But $25 is kind of what I use as a rule of thumb. So we were able to save 4 inches of gravel, and that's on the vertical axis. That's the thickness of the gravel section from 1 to 15. So if we look at 4 inches in savings, we're saving $5 a square yard by going from a biaxial grid to triaxial grid because of that performance difference. Now, of course, there's a cost of that grid, and just as a conservative number, you can say, all right, this TX130 is $2 a square yard, $2.50 even if you want. You're still saving $2.50 a square yard. Now, if we look at the highest performing, which is our Interax NX850, right now the highest performing on the market, you compare that, you're actually able to save 13 inches as compared to biaxial Geogrid of gravel, which, going through the same exercise, 13 inches of gravel, $25 a ton is $16.25 a square yard. Well, you may be spending $6 or $7 a square yard for the grid, but it still saves you $9 a square yard. So just in a real quick explanation of why biaxial Geogrid can actually cost more, that's an example. The second application is pavement optimization, and that's a kind of a nerdy Tensar word for thinning up the asphalt. And ASH293 is the design methodology most engineers use to design pavement sections, and that's what our methodology is based on as well. And our Paved software, some of you may remember our old Paved software. We now have a web-based program. It's called Tensar Plus, and what it did, it's taken Paved, it's taken Rail, it's taken all these different applications and putting it into one. It's web-based. It used to frustrate me before I came to Tensar, where I'd go in to do a design and I'd have to reload or upload Paved. Well, now since it's web-based, you can it updates overnight while you're sleeping, so you don't have to mess with that. And there's all kinds of applications that's going out through Tensar Plus. So if you're interested,
for people like me who haven't used that software as often, and we might need a refresher, what kind of training is available? And do you guys provide that?
We do, and I'd be more than happy to share it, to set up any kind of training session. And a lot of times, if you have a project within about 10, 15 minutes, I can run through it and show you. Or we can go, we've actually given some design workshop presentations to where we'll go through the engineering background of each module, and you can also get PDHs just because it's technical in nature. You may feel like you've been drinking out of a fire hydrant, and I've covered a lot of treetopped a lot of information, but this example kind of shows you how important it is to go through the proper steps. So this is how the process should work. We'll start with the positives. This is a Geotech report. You know, we get the information we need. This particular project is on the front end. They actually ran CBRs. You can also obtain CBR data using our software from the drilling, the geotechnical boring logs. But here, on the front end had a CBR value, so gave a recommendation based on the lab tested CBR values. And then I went out when they were ready to construct it. I confirmed that those CBR values were still in play, which in this case they were. We proof rolled to make sure there weren't any soft spots. And then we laid out the grid. And in this case, what it did, this was a win-win-win. Everybody won on this one because the original recommendation was 18 inches of undercut and replace because of the CBRs being in the range of 4 to, I can't remember the exact, it was on that previous slide, but memory serves about 4 to 5, which the geotechnical engineer had designed the pavements with a higher CBR. So they were going to have to require 18 inches of undercut and then replace with a higher CBR material. Well, based on my DCP data and the original geotechnical engineer's report, I was able to replace that 18 inches of undercut with a layer of grid. And on this project, it was a TX7. And the controlling factor was the construction traffic because it was going to influence the subgrade more so than the design traffic. So because of that, I was able to allow for a construction platform for this subdivision with city streets. And the city actually was able to realize a higher design traffic ESL count. And I keep saying ESLs, that's estimated single axle loads for those of you that aren't familiar with that. So everybody won on this one. And here you can see they haven't installed the utilities yet. Goes back to, well, can we dig through that grid? And the city said, well, I'll believe it when I see it. And here you can see, we have sewer pipe here sitting and storm drainage. I didn't hear a single word from anybody about issues with, and I knew there wasn't going to be because I'd seen it so many times. But basically what it did, because they had a construction platform and because they did not have to perform that undercut, scrolling through here, the benefits were about 300 grand. And this was a 60, 70 acre subdivision. So pretty sizable job, but based on what the contractor told me, they saved about $300,000 in just cost. And they were able to save about 8 weeks of time. And a lot of that savings this was constructed about this time of year, where we're starting to see a lot of rain. So they have built into their schedule, when you have rain on an exposed subgrade, you have to just sit back and wait for a few days. Whereas if you're already covered with gravel, the next day after the rain, they were able to go out and continue work and installing their utilities. So now moving on to how the process should not work. This was a project where I had a guy who sent me this picture, said, "Hey buddy, we're going to use some of your Geogrid on our job." I'm like, "Well, I appreciate that. What, tell me a little bit about it." So this is an off-road hauler stuck to its axles. It's not moving.
That's an awesome picture, by the way. The engineer in me loves that picture.
Yeah, well, it kind of scared me because this was the next picture I had, and I said, "Okay, well, tell me about it. What do you recommend?" And in the background, the sun's setting, and I told him, I said, "I'll be out there first thing in the morning because they're about to wrap up." And you can see also in the background they're placing gravel, so they're moving along with a recommendation. So when I asked the question, "What's your recommendation?" This was what he said. He assumed a CBR value of 1, so he said that's TX7 with 24 inches of gravel. Well, I said, "Well, okay, well, how did you get a CBR of 1?" And he said, "Well, the truck was stuck." And I said, "Man, let's go with 12 inches of that 24 and let's see what it's doing. I'll bring my handy dandy tool out. Let's quit shooting from the hip, man. Let's incorporate some actual data." And the old SpectraPave software had this graph, and in this gray area, what we have is on the x-axis, the CBR values descending from right to left, and then the aggregate fill vertically that is required on top of a particular geogrid. You can tell we really start getting vertical as we get softer and softer. So if you look at a difference between a CBR of 0.5 and 1.5, that's about 18 inches of gravel difference. So that's where you really need to. I hear a lot of contractors say, "Well, I've been doing stuff for 25 years." We've all heard that, and I respect that. I really do, but I don't think that anybody could accurately determine the CBR value within this range. It really takes knowing what's underneath the surface. And this is what we got. You may remember this picture from the beginning. This is 12 inches of gravel, and based on this, I could tell we need to look at this closer. This really isn't working. So I broke out my DCP, and the actual CBR value was a 0.35, and that's a lot different from a CBR value of 1. So that required a second layer of Geogrid. And actually, when I submitted my design, it required 22 inches of gravel with 2 layers of TX7. So we had 24 inches, so we knew we'd be safe. So that's what we ended up doing. And I say here, hindsight is 2020. And, the engineers looking at this that made the recommendation thinking, "Man, I see what you're talking about. Really should have evaluated the subgrade closer." And, this is a situation where the owners hacked, the contractors hacked, because the recommendation, the change order that went through, didn't work. So they had to allow for another layer of Geogrid.
Well, no wonder you were scared, because a lot of people underestimate how much of a difference that can make between a half CBR, 1 CBR, and 1.5. I've seen what you've seen. I was raised by a guy that laid pipe for a living, and I met guys who just stomp their boot heel in the ground and tell me what the CBR was. And I was like, man, I appreciate the old school. I really do appreciate a lot of the old ways. But when you're talking about that big of a dollar difference in timing on a project and whether or not it's successful, you're right. Nothing beats the data. Good job out of you.
Yeah. Well, and that's why we also, when we order a Geotech report, even if it's for a parking lot, we don't go 20 or 30 foot, but we need to go 5 or 10 foot below the surface. Again, a lot of that depends on grading, but we need to know there may be a crust out there that's passing a proof roll, and then a couple days into the job, that crust starts breaking down and you start getting trucks stuck. So, it's just a lot of times what's under the surface may be may be a little scary. So, you know, in Tensar, we provide other applications as well. As far as Geogrid, this is kind of a busy slide, but we've worked with actually Guy Lidikin on several projects where we provide a wall solution, whether it's a temporary wall, a reinforced slope. We provide shop drawings that are stamped and sealed by our in-house engineers. We also have asphalt interlayers, which, you know, basically is asphalt reinforcement. And this is an example of a project. This is in St. Charles. This was last summer. They were having a lot of issues with their pavement. So they wanted to find a way to, you know, they have a short window of construction for a school because you have 3 months to where you don't have a lot of kids on campus. So they really don't have time to do a full depth undercut and replace. So they wanted to come up with a solution where they could, over the summer, fix and try to slow down this reflective cracking. So we a contractor placed glass grid and paved over the top of it, and this is what it looks like now. Again, this is a year into it, but basically delays the reflective cracking that you'll see. And you know, I'm here. The reason why Tensar is here, whether it's me or my counterparts in the different regions, if you need a spec, if you're a designer and you need a specification to where folks will hold spec, we can give you a Word document you can put into your spec book. If you need site support, site assistance, whatever, that's what we're here for. Basically, in other words, you have an issue, just give me a call. Give me a ring, and I'll be more than happy to help you. And with the, I'll get a list of all the attendees. I'll send you my V card. That way you can have that information. And if it's not in my area, if not in my region, I'll be more than happy to set you up with the regional manager that is in your region. So with that, we've got about 10 minutes here for questions.
We do, and I can help with that. So I'm going to take over the screen. Okay. The reason I'm doing that is I'll stop remote control. I'll go back to something you have on here. And can you hear me all right with the audio?
Yes.
I want to make sure that, because while I was enjoying you presenting, I want to make sure that I didn't change anything here. One of the things that you mentioned, Lidikin, with the wall solutions, he used all of these. So he counted on your experience to provide a solution for a project, and he's recommended it for more than one project. But a few years ago, we have a traveling road show, Nathan, called Clean and Green that we did. We stopped doing it before COVID, or because of COVID. And Clean and Green, we would start out in Omaha, Nebraska, and then go to Des Moines, then Kansas City, Missouri, St. Louis, Missouri. We would do 4 cities in 4 days, and we would invite guest presenters, guest speakers, to meet us in those cities. And in Kansas City and St. Louis, Guy featured your Tensar wall system, and he counted on the experience, but he talked about all the above: site assessment, design assistance up front, writing a spec, holding the spec, and then site support. And those are things that we count on. So when I mention all of our sales folks, they're being experts, they are experts at what they sell every day. But they're also smart enough experts that if they get a challenging project or an opportunity, they are really quick to bring in me as a civil engineer to provide some support. But even better, that is an expert like yourself who's an expert in your products, specifically your applications. So one of the questions we have regarding price, we don't answer price on the webinar for a couple reasons, Steve. We cover a large market, and our local sales team, every one of them in every city, are able to provide pricing, up-to-date pricing in their market. And that's for biaxial, triaxial, Interax. And the only reason I'm hesitating to answer that right now, Steve, is if you pay attention to what's happening in the world, anything petroleum-based is subject to change. And the webinars we put up live today, if I gave you some pricing and answered it in this webinar today, by the time somebody accessed our YouTube video sometime this year, I can't guarantee that price would be the same. I will tell you, we'll be straight up front with you about the price when you talk to our local markets. And if you talk to me, I'll find out where your project is and get you connected with, I'll bring in the loop our ASP guys or Bowman folks. But we'll talk price right up front in more ways than one. So to Steve's question, if you guys were looking at the graphs and the charts there, Nathan shows a comparison. What happens if you do nothing? And the software will help you do this as well. For paved and unpaved roads, using their software, you can look at your options of do nothing, use the biax, use a triax, and use an interax. And then based on your local market, this is another reason I don't answer the question of the price to the contractor for the geogrids, is you also need to have a good idea of your local market price for rock. So Nathan mentioned $25. In some markets, that's really optimistic, especially with the price of fuel. Now, there are rock quarries readily available near St. Louis in that example, but I can tell you our Omaha office handles projects across Nebraska, and there are certain parts of the state where they may not have rock at a reasonable price. So if they could save rock by using Geogrid, they would absolutely see benefit from that. Nathan, do you want to chime in on that?
Well, and even beyond that, we can also, a lot of folks think of stabilizing subgrade as what Geogrid is for, but we're about to start our third project with Walmart, excuse me, on a distribution center where they have this large pavement area, 1 inch of asphalt. By using Geogrid underneath the gravel, it influences that asphalt toward if you can whittle down 1 inch of asphalt over an entire area, a lot of cost savings. So, that kind of goes into what, Bill, you were saying about the cost of gravel. Asphalt's also expensive. And
the software will help with that too.
Exactly. Yep.
Yep. And one of the things to piggyback on what Nathan said, and Nathan, I'd love to hear this. I was working with the city of Colorado Springs on a stormwater project, and we were looking at a project, and near a construction effort they were already doing along the interstate. And I said, boy, this isn't really a neighborhood that's conducive for hauling in rock. And the lady from the city of Colorado Springs says, you're not kidding. I'm in the stormwater side, but I share a building, and I correspond with the engineering public works side. They are really beside themselves because now they have to create 3 new projects to repair and replace side streets that led up to this urban section of highway or interstate. And people underestimate the power of hauling in rock on trucks. So depending on where you're at, it may just be more than a spreadsheet showing the dollar value of how much rock you're reducing or how much pavement thickness you're reducing. If you're reducing the impact on the surrounding area to get to that and the amount of fuel they're using, people are going to be in favor of it.
Yeah, and our software actually calculates that as well. It'll show you how many pounds of carbon for each option also. And a lot of...
I was going to ask that, but I wasn't sure. I was going to ask if you wanted to talk about that, because there's a lot of people that are really pushing for that. Is that something that you promote? Because I'm not aware of that part. That's happened since my time.
Yeah,
first using it.
Yeah, and one thing that probably 15 years ago, there was a city engineering staff that really liked grid, because also you look at the undercut options where you have to remove soft soils and replace. Well, that has a lot of issues. You have track out. You have loaded trucks beating up their existing street system. So if they can limit that, plus the fuel emissions, well, that kind of started this thought process. And then with the infrastructure package that came out, there's a kind of a focal point for green initiatives. And so you can look at the different options, whether it's undercut, whether it's using biaxial, triaxial, interax, and it'll compare the pounds of carbon used for each recommendation. So that can also go into the benefit cost analysis when you're considering a geogrid.
And I think it's nice to have options. So we have a lot of designers that come to our webinars or attend our conferences, and they're always looking for things that give them an advantage over their competitors, even in the design side. But if they can talk the talk and speak the language that the DOTs want to hear, DNR, EPA, any federal highway, any any projects that they have that might have those initiatives as a value item. It may not show up in a spreadsheet yet, but that is starting to happen too, where you talk about the value of somebody has to rank their priorities, right? Whether it be a DOT project or private development. Time might be the most important thing, as you said earlier. Weather is getting more and more unpredictable, and one of the things we have to do to be prepared for changing weather is try to speed up the time we have open pits. Another one would be liability. The longer you have any kind of an open hole, the longer your project and everybody involved is vulnerable to liability, whether it be from pedestrians, cars, the public in general. There's really a lot of value that is hard to show up on a spreadsheet, like I said, for risk management, time management, negotiating the weather. So these are things that we can help people talk about, and I'm sure with the education that you have available with all of your many webinars and blogs and just being willing to connect with us and do training, there's a lot of value we can add. These are things we didn't learn in college. Now, I'm quite a bit older than you, and I'm telling you, you've already seen it. And I say I'm quite a bit older than you because you look fit and you have young kids, but things have changed since we were in college, right?
Right.
Most of the things you and I talk about, we didn't learn in college. Maybe a DCP, we understood something about subgrade, but this industry is ever changing and evolving, which is why continuing education is important. So Nathan, I thank you for joining us today. We will get done here a little soon, I think. But one other question I have that came to me personally was when you mentioned filter grid, what fabric is attached to that? And I said non-woven geotextile, 6 ounce or 8 ounce. Is there anything else you'd like to share about that, to answer that?
No, you're exactly right. And when you go into our software, you can pick filter grid as an option, and it'll give you the specifics on it. But it doesn't. It's not meant to provide structural support. It's just for separation. The
Separation layer.
Support is provided by the Geogrid.
Thank you for that. So it usually works in harmony with a Geogrid, right? So
yeah, there's a lot of engineers that recommend fabric underneath the grid, and this just basically, we're working with ASP on a project for the Corps of Engineers where I don't know why, but the first layer they ordered filter grid, and then the second layer they wanted fabric and grid. Well, they ordered them separately, and then they said, well, why didn't we go with filter grid on the second? I mean, that's so much easier, and they were actually thinking about just going the other route with filter grid because it's you don't have the fabric blowing in the wind and fighting all that. So contractors like it. It's just easier to install.
Right. Well, I appreciate you working with our ASP branches, and I know you don't personally work out in Colorado, but Ryan Anderson at Bowman Construction Supply sent some people our way, and some of the folks that he sent that to actually communicate with our Kansas City office as well. And I know you cover Missouri, Kansas, and Arkansas, but you know everybody, you know your cohorts in those other states. One thing that happens to us sometimes, and happens to you as well, we might start a project conversation with somebody in our market to find out the project's located somewhere else. That's not a problem for us. We're happy to answer questions with anybody we know. So there could be some people that are attending here today that might be in one of those markets where we don't necessarily carry your product up front. We can put them in touch with you. And this is a small world, and especially with what we're seeing in the news today, we don't have time to have enemies or to be not playing as teammates. Nathan, I consider you a teammate, and in the short time I've known you, I really wish we could have done this in person together, sitting side by side. Right. So we'll have to do that next time. But I love working in harmony with everybody. So everybody that's on here, please, if there's a question that didn't get asked today, when Madeline Drury from our office reaches out to you at the end of this webinar, she'll ask you to verify your information. There may be a couple of questions. It's an opportunity for you to ask questions that you didn't hear asked or didn't think to ask, but also to bring up projects. You got specific projects you want to talk about, my guest here today would be very excited to talk to you about specific projects. And the weather allows, he's going to be out there with his DCP.
Exactly.
Nathan, anything in closing?
I appreciate you, Bill, for inviting me to talk.